physical properties of haloalkane and haloarene. I request you to go through my previous video of physical properties of alkanes, alkenes and alkynes. Will help you navigate through this topic better. Haloalkanes are actually colorless, but they develop deep color on standing because with sunlight the halides they react. Lower homologues, the lighter ones, they will be gases. As you go up, they will be liquids and then finally solids, as was discussed in the previous videos. Halogens will always have an electronegative element X, that is fluorine, chlorine, bromine or iodine, one or more attached to a carbon atom. So this is going to give the polarity to the haloalkanes. So with the polarity comes the variation in the property. So more is the polarity, definitely they will have a higher boiling point when you compare them with the hydrocarbon having similar molar masses. So due to the polarity, they will show increase in the boiling points. And if you compare for the same alkyl group, always iodides will have highest boiling point, followed by bromide, chloride and fluoride. This is because of the greater molar mass of the iodine. So greater the molar mass, greater are the van der Waals forces, greater is going to be the forces of attraction, hence the boiling point is going to be more. Also, for the isomeric halogens, as the branching will increase, the boiling point will decrease. So if you take N-butyl bromide, or you take sec-butyl bromide, or you take tert-butyl bromide, always tert-butyl bromide will have lowest boiling point because of the small amount of surface area which it occupies in the space. So the forces are going to be weaker and the boiling point is going to be lowest as compared to secondary followed by primary. For dihaloalkanes, always the boiling point is going to be the same. But when it comes to the melting point, always you will see that para derivatives 1,4 dihalobenzene will always have higher melting point than the ortho and the meta isomers. This happens because in para, the forces of symmetry they act, because para is more symmetrical. As a result, the force of symmetry will act, hence the melting point is going to be higher. Density of haloalkane is always greater than water. If we come to the solubility, although they are polar, they should show solubility in water. But it has been observed that alkyl halide, although they are polar, they are immiscible in water. The reason being that the forces of attraction between the halide and the water, they are not enough strong. The amount of energy which is liberated is not enough to compensate the amount of energy which will be required to break the bonds of water and the bonds of halides. So as a result, they seem to be insoluble in water. If you compare the solubility of alkyl halide to the aryl halide, always it has been taught to you that aryl halides will always show poor solubility because the aryl part is further hydrophobic in nature. Alkyl halides, since they are insoluble in water, they are soluble in non-polar solvents. That's all for the physical properties of the haloalkanes and haloarenes.